I'm back. It seems that you have uh, three pieces of recordings of the recording. I hope three and no more. Okay, now let's start solving the task. So nothing new for you, but just kind of review. So first of all, let's find the magnitudes of vectors. Magnitude of x equals square root of scalar product x by x. One plus minus 3 in square, and we have square root of 10. Then y magnitude of y the same way, and we have 2 in power of 2 plus 3 in power of 2, and it equals a square root of 13. And the scalar product of x and y equals 2 by 1 minus 3 by 3, and it equals 2 minus 9 minus 7. And then cosine of angles. So cosine of angle between vectors. We need to divide the scalar product by product of magnitudes. Or minus 7 divided by square root of 10 by square root of 13. And now let's do the sanity check, just to make sure that our result is adequate. So here we have 100 square root of 130, and minus 7 is minus square root of 49. And yeah, and so we can verify that it is so the magnitude of cosine is less than 1, so adequate result. Any questions about this task?
No questions.
Okay, no questions. Now let's do task number 6. So what do we have to do? We have 3 vectors. So we have bases of 3 vectors in Euclid space. And we need to find orthonormal basis. Do you remember what is orthonormal basis? What does it mean? Mikola?
A basis called orthonormal if if
So?
No, I can't say.
By the way, so orthonormal means that orthogonal and normal And what does mean each definition?
Or orthogonal is when a scalar product equals 0.
Yeah. So all these vectors in the orthonormal basis must be equal. So their scalar product must be equal to 0. Okay. And what does normal mean?
All vectors were normalized.
Yeah, they're normalized. These vectors are unit vectors. So each has a magnitude. So their magnitude equals 1. Okay. So first of all, we need to find orthogonal vectors. And then we will normalize. It will be much more easier. So we need to find vectors f1, f2, and f3. It will be their orthogonal basis. So first of all, f1 we will set as g1. So it will be this vector. So 1, 2, 3. Then we will find f2 with this expression. So g2. So we'll solve this task recursively. I guess you already know what does recursion mean. So we will have to find coefficient alpha 1 multiplied by f1, which we already know. And how to find alpha 1 basically. Alpha 1 with the upper index 2. Upper index means the iteration. So it's the second iteration so the second iteration for finding orthogonal vectors. And basically how to find alpha 1, 2. So it is minus scalar product of f1, which we already know, divided by g2, a vector scalar product of f1 and g2, and divided by the scalar product of f1 by itself. And what we actually have. So alpha 1, so f1 multiplied by g2. So it's the same as g1 by g2. So 1, no. So 0 plus 6 minus 6. So it's like a comfort coincidence for us. So f2 will be equal to g2. So it means that g1 and g2 are already orthogonal. And we already verified it. But the third iteration will be more complicated. So f3 equals g3. So this expression will be similar to this one, but we will have to add. So we need to find two coefficients alpha 1 with upper index 3 multiplied by f1 plus alpha 2 with upper index 3 multiplied by f2. So if we had more dimensions on each next iteration, we have one more alpha coefficient multiplied by f with index n minus 1. But now we just have to find alpha 1 and alpha 2 with the analogical way. So it equals minus. So for alpha 1, be careful, f1 multiplied by g3. So we need to multiply each by the g3 and divide it by the scalar product of f1 by itself. Minus, okay, let's multiply f1 by g3. So f1 is g1, so 0 plus 2 minus 3. And f1 by f1, it's 14. So it equals minus 1 divided by 14. And alpha 2, 3 equals minus, in this case, f2 multiplied by g3. So what changes here? F vector, but so what doesn't change? G3 is not changed, but yeah, and here we have f2 multiplied by f2. So in this way, and g3 remains without changes. So f2 by g2. So 0, 3 plus 2. And f2 multiplied by f2 because it's g2. So 9 plus 4. Oh, yeah, plus 4, not plus 3. And it equals minus 5 divided by 13. Okay. So it seems that everything is correct for now. Yeah, Daniil, any questions?
f2 is equal g2, yes?
Yeah, because they are already, so g1 and g2, they are orthogonal because their scalar product is 0. So it just, so it simplified our task on the second iteration.
Thank
Okay. So any questions by this time? Okay, it seems that no questions. So now we'll have everything to find f3. So let's start writing. Let's start calculation. So f3 equals, so g3, where is it? Okay, it equals 1 minus 1, 1. 1, 0, 1, and minus 1. So here is plus. So minus 1 divided by 14 f1, and f1 is 1 to 3. So we need we'll have to have fun with adding fractions. I guess you like it. Of course not. So, and F2 is G2. So 0, 3 minus 2. Okay, so let's move it to the so 13. Okay, I will calculate just a minute. I will multiply 13 by 14 on my calculator to save the time. Don't like this corrections, but anyway, we need to do it. So 182. So 182. So minus so minus 13 here. Cool. A 0 here and 0 here. Okay. Oh, by the way, it can we could just set 14. Okay. Next. So 182. Here we have as well 182 minus 26 plus 5 multiplied by plus 5 multiplied by I hate it. I had these fractions. Okay, 5 multiplied by 14 and multiplied by 42. That's a pain. I hope that we'll finish it without any mistakes. Because okay, and what we have here, so 182, so minus 3 by 100, minus 42. Minus, so we need to multiply 3 by 13 minus 39. Plus, so 5 by 2 by 13. Okay. So here we will leave just minus 1 by 14. And this will be calculated faster on the calculator. But need to verify it. Yeah, and I forgot the first vector in this expression. So minus 182. I guess you don't like fractions as well. So 182 minus 26 minus 5 by 3 by not by 32 but yeah, by 14 by 3. My bad. and not plus actually, not plus because of minus. So minus 52 divided by 182. Then minus 39 plus 130 and minus 182, minus 91. Oh, one second. So maybe I guess that this answer is correct. I hope. Anyway. Okay, now we need to verify that f3 is correct vector. Let's multiply first of all by f1. Okay, so 0 because no, 1, 2, 3. Okay, so minus 1 divided by 14 minus 2 by 4.
Sorry, but why minus 1 over 14? It's 1 without minus.
But we have here minus 1 by 14, or it. So
I understand. Okay.
yeah.
So,
Minus 3 multiplied by 91 and divided by 182. Okay. So let's calculate it. And what do we...
Can I ask a question?
Yeah, of course.
Can't we write minus 91 divided by 182 like minus 1 divided by 2?
Yeah, we can shorten it, but we need to... But we have also this fraction, so it has no sense for now. And it seems that we have a mistake, as I already see. So this is negative, negative, negative. So something is not correct. Definitely.
I have another answer. Is 1 over 14, 69 over 91, and minus 3 over 182.
Okay, let's try with this variant. So, yeah, let's recalculate with your answer because, yeah, don't like such fractions. So, what will be the first one? Over
1 over 14, yes.
without minus, yeah?
Yes, without minus.
But,
Second, my
but
is
yeah, I forgot about this minus. So yeah, that was a mistake. Okay, plus or minus. So
second my is 69 over 91.
69 over 91. Okay.
And third is minus 3 over 182.
So if we
And with,
yeah, and multiply by 3 as well.
and if we multiply 91 by 2 and 14 by 8, so we have 192, 82. No, yes, 13.
Yeah, so here is 13. So 4 by 69 and minus 9. Okay. But it's not 0 as well. By the way, yeah. Yeah, so it seems that I'm online. So F 3 coordinates for you. So 1 over 14, and then 69 over 91, right?
Yes.
And
So I'm also wrong.
yeah, and it seems that we are running out of time to recalculate the fractions. Maybe now anyone has a question about the exercise. So we already know how to solve it. So we need how to find orthogonal vectors, and the normal vectors will be just so we need to normalize them in the end, and then so it will be the solution. And now we will leave this exercise because we have no time. For task number 7, actually almost the same as task number 6, but even less actions. So we have already orthogonal basis. Yeah, first verify and then build orthonormal. And for task 8, now let's solve task 8 quickly. So what do you remember about unitary spaces? Or maybe some questions about task 6. Mykola?
Yeah, I have. Can we solve it maybe on a future consultation?
Yeah, sure. If, by the way, if you have a consultation with me, and also I will make so I will share with you materials with the detailed solution of this exercise, just for better understanding. Because yeah, we have a lot of fractions, and we get confused. So yeah, it's better to have already. So we need to have this task solved for your better understanding. So more questions? No questions. Okay. And I have a question for you. What do you remember about unitary spaces? What is it? So such kind of linear spaces. So I guess, as I understand, nobody remembers. Okay. So unitary space is as well kind of linear space. It's like a Euclid space, but it has complex values. You already know about complex numbers. So it has a real part and imaginary part, and so analogical to the Euclid space. So how it is actually defined? Well, so it has as well scalar product. And how does it look like? So we multiply x. Oh, oh, it's better to mark them as A and B. But it's so the scalar product in complex complex Euclid space or unitary space is also called as Hermite product. So AX no XA multiplied by XB and its complex conjugate, and YA multiplied by YB and multiplied by complex conjugate as well. So it means that their scalar Hermite product is so like as well. It has kind of anti-commutative like anti-commutative or just not commutative property. So we have such signs. So the opposite complex number. So the so scalar product of B by A equals the Hermite product of A by B equals complex conjugate product of B by A. Okay, and now let's solve it. Let's solve the task. So we need to find the Hermitian product. How to do it? Let's do it quickly. So we need to find A by B. So we multiply 2 by 3 minus I plus 2 minus I multiplied by 2. Nothing changes because y part of b is real. So what we have?
Why,
So you have question, right?
why did 3 plus I?
Because we need to multiply by complex conjugate. So it means let me remind you. So how we write a complex number? X plus I by Y, and complex conjugate equals X minus I multiplied by Y. So we change the sign of imaginary part. So did you understand what I mean?
Yes.
Okay. So 6 minus 2I plus 4 minus 2I, and it equals 10 minus 4I. And the magnitude, of course, will be a real number, and it will be of course, non-negative. And of course, we do as we did before. So 2 by 2. So because complex conjugate plus 2 minus I multiplied by 2 plus I, because here we have imaginary part. So according to this rule. So we have 4 plus 4 plus 1. And by the way, finally, we can even calculate the square root. It equals 3. Any questions about this task?
Why we change Xenon where 3 minus I, but we don't change where 2 minus I? It's also why?
So how you mean this part, right? A by B, right?
Yes.
So according to the formula, XA multiplied by X conjugate of B. So what we have? 2 multiplied by 3 minus I. So XA remains without changes. And the same with Y. So YA 2 minus I, so it remains without changes. Multiplied by 2, nothing changes because 2 has no imaginary part. So now, do you understand it?
Yes.
Okay, more questions? Okay, it seems that you have no questions, and now our lesson is finished. Have a nice day. Stay safe. I will share a recording with you a little bit later.